Welcome to our practice with stoichiometry. So over yesterday you learned how to use mole conversion factors to kind of convert between different substances in a balanced equation chemical reaction. So we are going to kind of practice all of those skills using mole conversions between mass, moles, and then also using the conversion factors presented by the coefficients in a balanced equation. All right, so we're going to start with the easiest type of problem. So let's look at question number 3 from the worksheet that I'm posting. So these are from the worksheet that you have. How many moles of KCl will be formed from 2.73 moles of KClO3? All right, so they gave you the equation here, very straightforward. So they're just asking you for a conversion between moles of KCl and KClO3. All right, now the beautiful part about a balanced equation is that the molar coefficients are the conversion factors. So you can read this just like a sentence. For every 2 moles of KClO3 that I will produce 2 moles of KCl and 3 moles of O2. Something very important to note, these are molar coefficients, not mass. All right, remember that you can't compare the mass directly between 2 different compounds because their relative sizes are different. So 2 molecules or 2, units of KClO3 is not going to have the same mass as 2 units of O2, which is why we use the mole. All right, so the first question is very straightforward. We're going to use dimensional analysis, so we're going to go ahead and set up the chart. And we always start, again, with the starting point, which is what's given to you. What's given is this, 2.73 moles. And it's important to put the substance that you're talking about, KClO3. Because when you're converting between compounds, you need to keep straight what you're in units of, okay? Now, we want to come out with moles of KCl, right? That's what they're asking us. How many moles of KCl will be formed? As you know, for dimensional analysis, the way that you set this up is the denominator of the parentheses should have the same units as the starting point because you want those units to cancel out. So we're going to have moles of KClO3 on the bottom. And the units that you want to come out of the dimensional analysis, you're going to put on top. So moles of KCl goes on the bottom. Moles of KCl goes on the top. Now, where do we get these numbers from? The numbers come from the balanced equation. So you just take the numbers that are written with the compounds. So KClO3 is 2. KCl is also 2. So you actually have a 1-to-1 ratio here, so you probably see what's going on already. But in case you don't, the units of mole of KClO3 cancels out. So we're left in moles of KCl. So the math that you would do here is 2.73 times 2 divided by 2. So you're going to get 2.73 moles of KCl. The reason is for that 1-to-1 ratio. But again, I just wanted to show you the dimensional analysis here. So let's go on to this question. How many grams of KClO3 are needed to make 30 grams of KCl? This is slightly more difficult. They're not asking you about moles, they're asking you about mass. And they're giving you a mass, and they're asking you for a mass. So you're going to have to do 2 more conversions than this problem. So you're actually going to have 3 conversions total. So let's kind of make a timeline of what's going to go on here. You're given mass of KCl, right? You somehow need to get to mass of KClO3, right? So first, you can't compare mass to mass. You always have to convert to moles. Something that's just a good kind of practice. Whenever you're dealing with stoichiometry, it's always good to go to moles. Whatever unit you're in, go to moles. So you're going to have to go from grams of KCl to moles of KCl. Once you're in moles of KCl, you can then easily transfer to moles of KClO3 using the balanced equation, and then you're going to get to grams of KClO3. So the number of arrows is the number of unit conversions. And let's just review, what does this mole quantity do? It allows us to go between moles and mass. The way that we do that is through molar mass. Okay, so less. All right. And this will be the molar mass of KCl because that's the compound that we're talking about. To convert between KCl and KClO3, this is where you need the coefficients from the balanced equation. Right? And then to go between moles and mass of KClO3, again, you're going to be using molar mass, but this time it's the molar mass of KClO3. So there are a few things that we need, right? There are a couple pieces that we're going to need to find. We're going to need to find the molar mass of KCl and the molar mass of KClO3. So why don't we kind of step back and do that first. If you recall, to find molar mass, you just have to add up the masses of the atoms inside. So for KCl, it's just going to be the mass of K and the mass of Cl. Okay, and that molar mass, when you add those masses together, is going to give you 74.55 grams per mole. All right, and when you do the mass of KClO3, right, that's going to be the mass of 1 potassium, 1 chlorine, 3 oxygens. Added together, you're going to get 122.55 grams per mole. All right. Now that we have all of our conversion factors and stuff, we're ready to set up our dimensional analysis. This one has more divisions because, again, we have 3 conversion factors instead of 1. Let's put in the starting point and the ending point. The starting point is what's given, so that's 30.0 grams of KCl. And my ending point, I want grams of KClO3. Okay? Now, what you can do with dimensional analysis, and what's beautiful about it is you can use the units, to direct the math, to direct, what's going on. What are you multiplying? What are you dividing? Right? So our first unit conversion, as we said over here, is from grams to moles. I'm starting in units of grams, so the gram unit should be on the bottom of my conversion factor. The moles should go on top, and again, we're still in moles of KCl. That conversion factor is here, 74.55 grams per 1 mole of KCl. When I do that, I get out of my unit of gram, and now I'm in units of moles of KCl. Okay, cool. However, I'm not done. Now I need to convert from moles of KCl to moles of KClO3. That's the whole point of balancing an equation. Okay, so coming back over here, 2 to 2, but I'm going to write them in anyway. So moles of KCl is the unit that I was left in, so moles of KCl is going to go on bottom. Moles of KClO3 is going to go on top. And again, you get these numbers from the balanced equation. 2 for KCl, 2 for KClO3. Okay? And again, because of my beautiful placement, I am now canceling the moles of KCl, and I'm in moles of KClO3. Not done. Now I need to convert to mass of KClO3 using molar mass. So I'm in units of moles, so moles of KClO3 goes on bottom, the mass is going to go on top. I know the molar mass because I found it over here. It's 122.55 for every 1 mole. And that will cancel out the mole unit, and I will be left in units of grams. So here's your equal sign here. So when you end up calculating this out, what you're going to do is you're going to end up with 30 times 1 times 2 times 122.55. All of that divided by parentheses. Please put the denominator in parentheses in your calculator. 74.55 times 2. And when you do all of that, maintaining your parentheses, you're going to end up calculating 49.3 grams of KClO3. So just a quick modeling of how to calculate some stoichiometry problems. Depending on what units you're using, it's going to change the number of conversion factors that you need, right? But the really important thing to remember is kind of the schematic for how you use a balanced equation and how you use the mole and molar mass to get between these units, okay? So The new piece from the chemical reactions unit would be that the balanced equation gives you the conversion factors to convert between different substances. Okay, so one new piece, but otherwise this is kind of picking up from our mole discussion. Good luck. If you have any questions, drop me an email. Good luck.